Section 2.3 is called Solving Linear Equations in One Variable. This section is really just a review of all the things that we've done so far in this chapter. There's only one part, Part A, Solving Linear Equations. A linear equation is any equation that can be written in this form: ax plus b equals c. And by that, what we mean is, for example, 3x plus 2 equals 10 is a linear equation because it's in this form. A, b, and c are just numbers. Here's another example of a linear equation. 5.1x minus 6.8 equals 3.9. Here's A, 5.1. B is actually negative 6.8. And C is 3.9. Now these are all linear equations already in the form ax plus b equals c. But sometimes you'll see an equation like this: 5 minus 6x equals 0. This is also a linear equation, but it's not in the form we recognize. To put it in that form, I can use associative, commutative properties of addition and multiplication, the distributive property if necessary, combining like terms, and any of the other rules and properties that I've learned so far in this chapter. In this case, I simply need to use the commutative property of addition to reverse the order of the terms on the left-hand side. If I rewrite this equation, negative 6x plus 5 equals 0, then my equation is now in the form ax plus b equals c. Once an equation is in this form, we can take quite a formulaic approach to solving it. I only have one x, I have constants on both sides, so by removing the constant that's attached here, my equation comes to this form. Then dividing both sides by the number in front of x gives me my answer. So once in this form, add or subtract this number from both sides and divide both sides by this number. And there's your answer. In general, I subtract b from both sides. Here I just have c minus b, which, although I don't know what they are, when combined, just gives me a number. And then divide both sides by a. My result is whatever c minus b is divided by a. So the benefit of having an equation in this form is that we know exactly how to proceed to solve it. That's all very nice. The problem is that we don't usually get equations given to us in that form already. We have to find a way to put them in that form. Once they're in that form, add or subtract, and then divide. Here's an example. This equation is not in the form ax plus b equals c. In order to get it into that form, I need to get rid of the parentheses by using the distributive property. 2 times x plus 2 times 3. Notice that I've written down the equals 10, primarily because I don't want to forget that it's there. If the left-hand side of this equation equals 10, then changing its form does not change the fact that it's equal to 10. Continuing, I can simplify the left-hand side, and now this equation is in the form ax plus b equals c. Because it is, I can subtract 6 from both sides and divide both sides by 2. Here, x equals 2 is my solution. Of course, we can also multiply both sides by 1/2. 1/2 of 2 is 1. 1/2 of 4 is 2. I still get the same answer. Here's another example, but in addition to distribution, I have this plus 4 hanging off the end here. I can either subtract 4 from both sides of my equation before I distribute, then do my distribution. 3 times 5 is 15. Now it's in the form ax plus b equals c. Instead of subtracting this time, I need to add, simply because I need to do the opposite of whatever this operation is in order to get rid of that number hanging off the end there. I get 3x plus 0 equals 24. Now I can either divide both sides by 3, 24 divided by 3 is 8, or I can multiply both sides by 1/3. 1/3 of 3 is 1. 1/3 of 24 is 8. But there's another approach I might have taken. Instead of subtracting 4 from both sides first, I could have done my distribution first. 3 times x is 3x minus 3 times 5 is 15 plus 4, just because I don't want to forget it, equals 13. Combining like terms gives me 3x minus 11, because negative 15 plus 4 is negative 11, equals 13. Now the equation's in the form ax plus b equals c, even though b is negative 11. Adding 11 to both sides gives me 3x equals 24. And multiplying both sides by 1/3 gives me 1x equals 8. Here's another example. This one has parentheses on both sides and fractions. But distribution is distribution. Let's start by distributing the number in front of the parentheses across the sum on the left-hand side. Instead of doing the arithmetic as I go, I'm going to rewrite this as 5/6 times 6x plus 5/6 times 12. But then don't forget the plus 1. This equals, now on the right-hand side, the same thing. To get rid of the parentheses, I need to use distribution. 2/3 times 9x minus, this time, 2/3 times 3, and then plus 5. Going back through this problem, I can see I have a multiplication here, an addition, multiplication, addition, this is my equals sign, multiplication, subtraction, multiplication, and addition. So I'll need to do these multiplications first, from left to right, on each side of the equation. Then I'll come back and do the addition and subtraction. 5/6 times 6 is the same as saying 5/6 of 6. 1/6 of 6 is 1. So 5/6 of 6 is 5 times that, or 5 times x. Plus, here I'm just copying down the plus, as I'll do over here, as well as here for the minus and here so that I don't forget to do these later. What I'm going to do at this stage is multiplications. 5/6 of 12. 1/6 of 12 is 2. 5/6 of 12 is 5 times as much as 1/6. 5 times 2. Plus 1. 2/3 times 9x. 2/3 times 9 means 2/3 of 9. 1/3 of 9 is 3, so 2/3 of 9 is 6 times x. I've forgotten my equals. 2/3 times 3 is 2/3 of 3. 1/3 of 3 is 1, so 2/3 of 3 is 2, plus 5. Now all I have is a plus, a minus, and a plus. So I'll do these left to right, but I'm going to do them on this side separately and then on this side. 5x plus 10 doesn't simplify. Here I have 5 x's and 10 1's. But here I have 10 1's and 1 1. So I can write the left-hand side as 5x plus 11. And I can write the right-hand side as 6x minus 2 plus 5. We're getting closer, but I still have x's on both sides of my equation. To get all of the x's over here so that my equation is in the form ax plus b equals c, there are no x's on the right-hand side. In order to get my equation into that form, I need to get rid of the x's that are on the right-hand side. So I'm going to take them away from the right-hand side. But of course, if I take them away from the right-hand side, I must also take them away from the left-hand side. 6x minus 6x is 0. 0 plus 3 is 3. On the right-hand side. On the left-hand side, I have 5 x's, and I spend 6 x's. So I'm overdrawn 1x, and I still have 11 1's. Now my equation is in the form ax plus b equals c. So now I'm ready to use the technique I showed you at the beginning of this section. Subtract 11 and divide by -1. I've removed all the work that I did before because I've run out of room. This line was at the end of the previous work and I've moved it up. So this line here is this line simplified without all the work shown. My equation is in the form ax plus b equals c. So I'll subtract the 11. -1x plus 0 equals 3 minus 11 is -8. And then divide both sides by -1. I'm dividing by -1 because that's the number stuck to the x. A negative divided by a negative here is a positive, leaving me with just x. 1x, or just x. And a negative divided by a negative here is also a positive, and 8 divided by 1 is 8. There's my final answer. This is our last example for this section. Whenever you see parentheses, when solving an equation, your first instinct should be to try to remove them using distribution. So that's what I'm going to do here. Notice that I have a negative in front of these parentheses, which I can think of distributing as the negative. In other words, -2x, then -4. Or I can write the invisible 1 in front of the parentheses and distribute by multiplication the -1. -1 times 2x. And negative 1 times negative 4. A third way to think of this is minus everything that follows is like saying the opposite of everything that follows. So think of this as the opposite of 2x and the opposite of negative 4. I'll do the same thing here. This is going to be the opposite of 4x and the opposite of positive 5. So let's get started. 3 times 2x and 3 times negative 5. And the opposite of 2x and the opposite of negative 4 equals 6 and the opposite of 4x and the opposite of 5. The associative property multiplication lets me reassociate the 3 and the 2. 3 times 2 is 6. 3 times negative 5 is negative 15. Copying the rest down, I get negative 2x, or minus 2x, plus 4 equals 6 minus 4x minus 5. That's simplifying my multiplication. Now we'll go back through and combine like terms. I have 6 x's here, and I want to spend 2 x's, so I'm left with 4 x's. I have a debt of 15 ones, and I find 4 ones, so I have a debt of 11 ones. Notice that as I work through this problem, I'm keeping all of my efforts either on one side of the equation, one side of the equal sign, or the other. I haven't done anything to move something from one side to the other yet. That's a good rule of thumb. Simplify the left-hand side as much as you can. Simplify the right-hand side as much as you can. And only when you've got it down to as few terms as possible, only then should you add something to both sides, subtract from both sides, multiply or divide both sides. So on the right-hand side, I have 6 and a minus 5, so I get 1 minus 4x. Now in this case, I put the constant first and the term of the x in it second. It doesn't matter. I could just as easily have written the minus 4x first and then said 6 minus 5 is 1. Either will work. Remember that in this section, our goal is to get the equation into the form ax plus b equals c. And we're almost there. We have ax plus b, but we have x's on this side too. We don't want those there. There are no x's on the right-hand side of this equation. So if these are here, they're essentially in our way. We need to get rid of them. To get rid of negative 4x's, I'll add 4x's. But if I add to the right, I must also add the same amount to the left. Minus 4x plus 4x is 0, and 0 plus 1 is 1. Here I have 4x plus 4x is 8x minus 11. Now the equation's in the right form. ax plus b equals c. b is negative 11. So the next step is to add the constant to both sides. This becomes 0, and I have 8x equals 12. If 8x equals 12, the last step is to divide both sides by 8. 8 divided by 8 is 1. And 12 divided by 8 can be reduced. The number that goes into both 12 and 8 is 4. 12 divided by 4 is 3. 8 divided by 4 is 2. I don't need the 1. So my solution is x equals 3/2. We haven't been checking our answers in the videos. We really should. I can confirm that when you check this answer by replacing every instance of x with the number 3/2, you end up with a true statement, which tells you that the number you were testing works. This is the correct answer. When I started this example, I said this was the last one for this section. I've actually got a couple more I'd like to do for you, but I'll do them in a separate video. There are special cases when, as you do the work, you come to the conclusion that the answer you end up with either doesn't make any sense at all, or it makes sense regardless of what value x might have. So let's take a look at those cases, but as I said, I'll do them in a separate video.